Satellite imagery reveals that in late August, Nepal's physical geography was rewritten in a single afternoon. A wall of water up to 100 meters high ripped through the mountain valleys. This surge accelerated to 115 kilometers per hour. At that speed, the water travels roughly 32 meters every second, making escape impossible for anyone caught near the riverbanks. The human and economic costs were staggering. Over 500 people are confirmed dead, with initial property damage estimated at $1.3 billion. Many victims were foreign laborers trapped deep inside hydropower tunnels, where the rising silty water left them with no route for escape. Geologists monitoring the site determined this was not a standard seasonal flood or a typical earthquake. They were looking at an unprecedented geological event. The danger remains active today. Upstream, a massive landslide has dammed the confluence of the Chochinkola and Purgu-Tangso rivers, creating an unnatural barrier lake. This temporary dam currently holds back 2 million cubic meters of water. If the debris wall fails, a second, equally devastating surge will sweep through the lower valleys. The disaster raises two urgent questions. How does a frozen peak spontaneously liquefy into a tsunami? And why did the entire region receive zero warning before the impact? Geomorphologists studying satellite data discovered that this was a total failure of the mountain's underlying bedrock. The Himalayas are shaped by tectonic plates colliding, pushing mountains upward 20 to 22 millimeters yearly. This rapid uplift creates microtremors, expanding internal stress fractures. As climate warms, the ancient permafrost acting as frozen glue inside the rock melts, leaving massive sections of the mountain face prone to sudden collapse. When geological instability meets rapid climate change, a catastrophic collapse becomes a mathematical certainty, requiring only the slightest trigger to release millions of tons of debris. This specific collapse began at high altitude, originating on the Tibetan side of the border. The resulting flood took approximately 45 minutes to travel from its point of origin in Tibet down into Nepal's Bote-Koshi River. Despite having sophisticated satellite tracking and real-time monitoring systems, Beijing issued no alerts to the communities living downstream during that 45-minute window. Local Nepalese authorities were blindsided, only discovering the scale of the disaster through panicked phone calls from eyewitnesses as the water reached their doorsteps. In the aftermath, Nepal is operating with transparency, accepting international aid and allowing foreign journalists to document the rescue efforts in the flooded streets. China, conversely, has moved to censor the event. Disaster footage is being removed from social media platforms like WeChat, and reporters are restricted from accessing Tibet to assess the damage. Hoarding environmental data and blocking transparency prevents neighboring nations from preparing for shared risks, turning a geological failure into a preventable humanitarian crisis. The destruction in Nepal serves as a warning for a larger, planned transformation of this fragile landscape. China is moving forward with the Motuo Dam on the Brahmaputra River, a project located in these same unstable upper reaches. This $67 billion project is designed to generate 60,000 megawatts of power, which would make it the largest hydroelectric dam ever built. By damming the Brahmaputra, Beijing would gain physical control over the river's flow, granting them the capacity to obstruct up to 80% of the water supply that currently reaches downstream India. However, this massive engineering project is being situated directly atop the same volatile fault lines and melting permafrost that caused the August collapse. Tectonic reality is already challenging these engineering ambitions. In January 2025, a 7.1 magnitude earthquake struck Tibet's Shigetse prefecture. The tremors damaged 14 regional dams, forcing the emergency drainage of 3 facilities as their concrete walls began to crack and tilt under the pressure. If a bedrock failure similar to the one in Nepal were to occur at a site as large as the Motuo Dam, the resulting surge would threaten the safety of entire downstream nations. Engineering cannot override the movement of tectonic plates. If superpowers continue to build on these melting fault lines, the next major collapse will place the lives of hundreds of millions across Asia in the direct path of a catastrophe.